All right, let's take a look at a second example. So here, for the second example, engineers must consider the breadths of male heads when designing motorcycle helmets. Men have head breadths that are normally distributed with a mean of 6.0 inches and a standard deviation of 1 inch. We want to find the probability that a single randomly selected male will have a head breadth of less than 6.2 inches. Right? And so, again, we have our normal distribution. We know it's normally distributed. How do we know it's normally distributed? Because it says it in the problem. It's normally distributed. It's normally distributed. The mean is 6.0. We want to know what's the probability that it has a value less than 6.2, right? So somewhere to the right is a value of 6.2. We want to find what's the probability we're to the left of 6.2. So what we need to do is we need to convert that 6.2 to a z-score. So z is equal to x minus the mean over the standard deviation. Our x value is 6.2. The mean is 6. And the standard deviation is 1. So we get a z-score of 0.2. That 0.2 is not the answer. Again, we need to go to StatDisk and plug that 0.2 into StatDisk. Right? And so in StatDisk, we are going to choose Analysis, Probability Distributions. We are dealing with a normal distribution. And so our z value that we calculated was 0.2, not .w, 0.2. And we evaluate that. We get a z-score. We are looking at the area to the left. And so our area to the left is shown as 0.5762, 0.57926. That is the probability to the left. That's the part of the curve that we shaded. We wanted to know what's the probability it was less than that particular value. So 0.57926 is our probability. Right, the second part of that says, let's imagine we don't select a single individual, but now let's say we are selecting 100 randomly selected individuals. Now we want to know what is the probability that for those 100 randomly selected individuals, what's the probability that that group will have a mean head breadth less than 6.2. Right? So we're no longer talking about choosing an individual, we're choosing a group of people. And so this is where our central limit theorem applies. Remember, the mean of the means is still going to be the same as the mean of the individuals, so it's still 6.0. We want to know what's the probability that our mean value is smaller than 6.2. So we're going to shade the area to the left of this. And it looks similar. I've fudged a few things here. Our standard deviation has changed, right? So how did our standard deviation change? Right. Sigma, the standard deviation of the means, is the standard deviation of the individuals divided by the square root of the sample size. So for the individuals, that standard deviation was 1. Sample size is 100. And so when we do this, we get a new standard deviation of 0.1. And now we are going to convert our data value, the 6.2, we're going to convert that to a z-score. We have 6.2 minus the mean of 6.0 over the standard deviation of 0.1. And so we get a number of 2. So our z-score is 2. Remember, that is a z-score. That is not the probability. We are not done yet. So we're going to take that z-score. We're going to go to StatDisk. So we went to normal distribution. I'm going to plug in a z-value of 2. So 2 is the z-value, and I'll evaluate. The area to the left of that is 0.97725. 0.97725. That is the area to the left. So that is the probability that a group of 100 randomly selected males will have a head breadth less than 6.2 inches. So, based on the information from above, could you conclude that all but a few men would be able to wear helmets for those with head breadth of less than 6.2 inches or less? Why or why not? Right, so which is more meaningful, the 0.57926 probability or the 0.97725? Well, you should ask yourself, are helmets worn by an individual or are they worn by groups? And helmets are worn by an individual. So what's true of the individual has more impact than the entire group, right? So if I have a little bit of extra space in my helmet, I can't share that space with you or someone else. They can't put part of their head in the same helmet, right? That doesn't make sense. So the 0.57926, the individual probability is more meaningful, right? And so I would say, could we conclude that all but a few men could wear helmets? No, we can't make that conclusion. Only about 57.926% could wear the helmets. Right? The individual has more impact than the group in this setting. It's different than an elevator. The elevator, the group has more impact. If I am overweight and someone else is underweight, then our two weights combined, like we can share that space, right? We can make up for those, right? All right, so that is the second example. In the next video, we will look at our next chapter, our next section in chapter 6. All right, we'll talk